A of this unit, which is to write linear equations. Part B is the same exact objective. It's going to be far different, but it is the same idea in that we are writing linear functions instead of linear equations. So the only difference between those two things is that an equation is y equals, and we've been using mx plus b. Well, a function, you simply use function notation. F of x equals mx plus b. Unfortunately, we will be modeling something different. Every question so far has been information that's easy to write an exact line, either the graph of the line or an equation or just 2 points. Now we're going to use it to model a set of data rather than given information. And what I mean by a set of data is that it's going to be some sort of real world context, which makes the equation much more difficult to do. So when we get onto this, and I'm going to go ahead and fast forward to wherever it was, looks like right here. Okay, this is what I'm after. I'm going to give you some sort of table of values, but it's going to have a real world context. So in this first example, the real world context was how much tip I had to pay for the cost of certain meals. And my job is to do 2 things. First of all, write the equation or the function that best models that, and then use this information to figure out how much tip I should get on that bill. Luckily, we have the calculator to do most, if not all, of this for you. Your calculator is set up to do this. Now, I do want to go over what this is. What we would have to do back in the day was we'd have to plot each one of these points, 1, 2, 3, 4, 5, on a graph, and then you'd have to come up with the line of best fit that best modeled this data. And this was called a scatter plot. But we're doing the same thing. Your calculator is set up to do this automatically. So we're going to go ahead and take advantage of it here. So, when I bring up my calculator, the moves to do this are very complex. So, be prepared to pause this quite a bit, and then we'll move on and come back. And I'm going to actually copy some of these screenshots right on here for you as well, so we don't lose them. So there's going to be quite a bit going on. All right. So, first step. I need to get this data into my calculator. So we're going to hit Stat, because we're doing statistics, and then we want to go to Edit, which brings up our table of values. Now, some caveats to this table of values. We're going to make this our X column, and this our Y column. So X comma Y. Well, that means over here, you all need to decide which one's X and which one's Y. And to me, because we're trying to figure out tip, we're going to want the tip to be our Y value. That way we can actually figure out, okay, Y equals, and we can just plug in the cost of the meal, X. It turns out it doesn't really matter which one you do, but you're going to need to be consistent and have those labeled. So all we do is go ahead and type in our values. 4.75, 6.84, and of course I covered up that last one, 8.97. And then we go over the other side and type in that. Give it a once over to make sure your columns are even, and these should all match up. So 12.25 should be right across from 1.5. Okay, now that we've got that, we're going to go back to Stat, And now we're going to go to calculate. And we can see in calculate, there's a bunch of stuff here. This actually goes on quite some way. What we're actually writing is something called a regression equation. And you can see right here, regression, regression, regression. And our job is to do a linear regression because we're writing a linear model. So right here, we want to hit linear regression. And now we can just bring this back up and enter one more time, and there you go. So you can see our calculator is telling us exactly what that value is. And I was gonna, like I said, I'm going to screenshot this just so we have it available to us. Now, my actual equation, that's too much. What we got going on here is that your calculator is best fitting it, so it's never going to be a whole number. But we can simply round this. And for our purposes, I'm fine with you rounding to 3 decimal places. I'm also perfectly fine with you not writing this as functions. But simply writing it as an equation. That would be fine too. Now, that's our first step to write the equation. We want to use that equation. So I'm going to write it down here. And we want to solve it when that is 10.5. Remember, I said it was important to know that the meal cost was my x value. So that when I come down here, 1.57, I can simply substitute that value. And when I go, I'll know that because my tip is the y value, I can simply plug that in. Now, I'm going to type that in as is into my calculator. And I get that the tip is that. And we're going to remember we're dealing with dollars and cents, so we should call that 135. Okay. So let's try one more, although I think we can probably see at this point that we might not even need another example, because all of these will have very similar things. When you get down here to the last few, we are actually doing something a little more advanced. So I'm going to do number 6. Now, when I look at this, it's important to digest the problem. First of all, since 1999, we've been doing with fireworks, and T represents, so we're going to make X my years, and then Y is the fireworks that are being used. Because then I can solve by plugging in 2008 and solve that for Y. That's also telling you what the equations are. Now, it's also telling you that they want T to be X and P to be Y. So when we write our equation, we'll just want to remember that as far as writing our variables. But the actual process to sub this in is the same. And they've given you the chart. So let's go ahead and do that. Now, we're going to have that information from our last stat edit already in here. So all you do is highlight L2 and click clear enter. Highlight L1, clear enter. And now it's a matter of typing in these two values. Now you can see I I've clearly made an error here because these are not lining up. So, where did I go wrong? That looked pretty good. I'm missing 6 here. There we go. There we go. Okay. So it's important that we check that, and it's real easy to see when they didn't line up like that. Now I'm going to do stat edit, whoops, stat calc, linear regression, and there's my equation. And this is just me copying this, so we have it to work with on our slide. And there you go. So, my equation that models this, let's round it off 3 places. So, it's going to be y equals, but again, well, let's go ahead and do y equals 8.187x plus 72.786. And it's important to go 3 decimal places. Now, remember I said t was x and p was y. So what they want you to do is they want you to write p equals and t. Like that. Now, here's the key. If I want to evaluate what year the year 2008 will be, we're not going to plug in 2008. This problem, and most problems with time, will use a scale. So 2008 does not go here. Sometimes it can, but this used a scale. Whoops, that deleted the whole thing. And the scale was that since 1990, so 1990 was year 0 in this. So 2008 would be how many years from 1990? Well, it would be 18 years from 1990. So see, they set up a scale, and while it can make our equation easier, it can also be a little more challenging to do. Once you figure that out, it's a matter of typing in, and according to this, I'll get 220 point, and everything was else. Point that. And again, let's round it so we're consistent with the rest of the problem. So that's what we're doing in our last section, simply a stat edit. Some students have trouble with this, and then some pick up with it right away. It's a matter of practice. However, this has a very nice little spin-off application for you all. When we go back to that section we just did, and we're going to do this 75 for us. It turns out that our calculator will do this too. It will make a scatter plot of that point well, that was the wrong one. Oops. Well, your calculator's not going to do this because you probably already figured out this was an x equals equation. So let's go back. I didn't catch that. Let's go back to one that will work. All right, this one, 70. So on 70, there's my scatter plot of 70. And your calculator will do a line of best fit for that scatter plot. Well, it turns out there is only one line that can possibly go through those 2 points. So we can enter this data in exactly as it looks. Now, it'll take some cleaning up. First of all, we have to make this into a table. First point, second point. So it's important to have a table, or at least recognize what that would look like as a table. Now, we can do the scatter plot, the stat edit, just like we did before. So, stat edit, and again, I'm going to clear out our old problem. 4, -2, -1, 1. Okay. And then we can go to calc, linear regression, and look at that. Ideally, this is the exact same answer that you had gotten. Now you're going to have to, if this comes out as decimals, you're going to have to know how to convert this to fractions. And that can be a challenge. So it's good to know both ways. For instance, if you don't know that this is -1/3 x plus 1/3, then that can be a pretty big hurdle to get over. But if you can do that, then this will work for every single problem. The choice is really yours. I had you guys do it by hand first, because the fractions can get a lot of people, and there's no way in your calculator to convert from that screen that I had shown you to a fraction. You'd have to retype it. And I see a lot of students go wrong oftentimes when they try to transfer that and type it. But if you're able to convert from fractions and realize that 0.3 repeating was 1/3, then this is a real good option for you. The choice is obviously yours come quiz time. I don't care which way you do it, as long as you're getting the correct answers. Okay, so at this point we should be done with our packet, and we are now officially done with the videos for Chapter 3. So take a moment, go over this whole packet, and when you're ready, come up, get that answer sheet from me, and check your work, and we'll be ready for a quiz sometime here this night. Good luck to you.